Let x be a discrete random variable taking values in the set of positive natural numbers. We are asked to find the value of little x such that the probability of x equal to k is exponential of minus 5xk. Then compute the expectation as well as the variance of x.
As a matter of fact, x is a discrete random variable taking values in the set of positive natural numbers. We know that the sum of all probabilities should add up to 1. Consequently, the sum for k going from 1 to infinity of exponential of minus 5xk should be equal to 1. The summation of the probability of x equals k, for k going from 1 to infinity should be equal to the summation of exponential of minus 5xk for k going from 1 to infinity. This implies that, we factor exponential of minus 5x out and we see that the sum of probabilities is equal to exponential of minus 5x times the summation of exponential of minus 5xk minus 1 for k going from 1 to infinity. We rearrange the indexes and see that the sum of all probabilities is now equal to exponential of minus 5x times the summation of exponential of minus 5xk for k going from 0 to infinity. This is in fact a geometric series with ratio equal to exponential of minus 5x. As a result, the sum of all probabilities is then equal to the fraction exponential of minus 5x over the quantity 1 minus exponential of minus 5x. Consequently, we should solve the equation exponential of minus 5x equal to 1 minus exponential of minus 5x. This equation is equivalent to the equation exponential of minus 5x equals 1/2. The final solution is x equal to the fraction negative logarithm of 1/2 over 5. Let us compute the expectation of x. Remark that the standard geometric series with ratio t converges absolutely to the quantity 1 over 1 minus t as long as the absolute value of t is strictly less than 1. When we differentiate this geometric series, we see that the series of derivatives that has leading term, k times t to the power k1, converges to the derivative of the sum which is, the fraction 1 over the quantity 1 minus t square. We will use the series of derivatives of the geometric series to compute the expectation of our random variable x. If we multiply both sides of the previous equation by t, we see that the sum for k equal to 1 to infinity of k times t to the power k is equal to the fraction t over the quantity 1 minus t square. Therefore, the expectation of x which is equal to the sum for k equals 1 to infinity of k times 1/2 to the power k is equal to the fraction 1/2 over 1 minus 1/2 square, which is simply equal to 2. Thus, e of x is 2. In order to compute the variance of x, we will repeat the same process. We will differentiate the series kt to the power k, for k going from 1 to infinity. When we differentiate the series, we see that the series with leading term, k times k minus 1 times t to the power k minus 2, for k going from 1 to infinity converges to the fraction 2 over the quantity 1 minus t cube. We first multiply both sides of the previous equation by t square, then break the resulting series as a difference of two series. The sum from 1 to infinity of k square times t to the power k, minus the sum from 1 to infinity of k times t to the power k. This allows of the derive the sum of the series from 1 to infinity of k square times t to the power k, as the quantity 2t square over the quantity 1 minus t cube plus t over the quantity 1 minus t square. It comes that, the sum of the series from 1 to infinity of k square times t to the power k is equal to the fraction with numerator t times, the quantity 1 plus t and denominator the quantity 1 minus t cube. We then apply the formula in order to simplify the expectation of x square. It comes that e of x square is to 6, since exponential of minus 5x is equal to 1/2. Finally, var of x is equal to e of x square minus the square of e of x. Thus, the variance of x is equal to 6 minus 4. In sum, the variance of x is 2.
Thank you for viewing this video. Please subscribe to our channel. We have an extensive collection of calculus videos covering limits, derivatives, series, integration, and many other calculus-related topics such as probability and differential equations.